Hello, geometry students. We are continuing in chapter 8 with 8.5 circles. And circles are, I love circles because they're all around us. They're fun. And circles are probably one of those things that you've studied multiple times over the years in math. So hopefully this is mostly review for you. This is going to be a pretty quick lecture talking about the area of circles. So as you look at these shapes, you'll notice that we start out with a three-sided figure inside a circle, and then 4, and then 5, 6, 7, and 8. So we're increasing the number of sides of polygons that are inscribed inside the circles. And what do you notice as we get more and more sides? Well, you might notice, well, in layman's terms, you might notice that the sides get closer, the sides of the polygon get closer to the side of the circle. Let's put that in mathematical terms. What is happening is that the length of the apothem, I just totally forgot a letter. Apothem is getting closer to the radius of the circle. So by way of review, remember the apothem is on a regular polygon. Assume that I sketched a regular polygon. It's the distance, the apothem is the distance from the center of the shape to the side where it makes a 90 degree, okay, a 90 degree angle. And so the as you increase the number of sides of your polygon, that shape gets closer and closer to the area of a circle. Now imagine if you had a polygon that had 1,000 sides. It would be so close and so tight against that circle that it would be almost the same. Now, in reality, it wouldn't be, but it would be so close that they would almost be differential from each other. And so that is important. That is important to keep in mind. So as the length of the apothem gets closer to the radius of the circle, then we can also see that the area of the polygon approaches the area of the circle that it's circumscribed in, or that it's inscribed in of the circle. Okay, so the area of the polygon, wow, I am just not doing very well with spelling today. The area of the polygon approaches the area of the circle. Now, this is really useful for us because it can help us to derive the formula for area of a circle from what we already know. So remember from the previous lecture that for a polygon, right, an n-gon that you would just put in however many sides there are. For any polygon, the area equals 1/2 times the apothem times the perimeter. Okay, 1/2 times the apothem times the perimeter. So we can substitute these the equivalent values on a circle. So 1/2 stays the same, but then the apothem, right, as we get more and more and more sides, the apothem approaches the radius of a circle. So we can replace apothem with radius. And then the perimeter, we have a special name for the perimeter of a circle, and that is circumference. So from the equation that we have for the area of a polygon, we can derive the area of a circle. Now you're probably looking at that and saying, that is not the area of a circle formula that I have memorized before. You are right, because we need to keep going. We need to go ahead and replace, we're going to replace the formula for circumference, right? Circumference is 2 pi r, 2 times pi times the radius. Okay, so we substitute, get rid of the c and put in 2 pi r there. And then we get 1/2 r times 2 pi r. And you're still saying that is not the area formula that I have memorized. Correct, because we can simplify, right? When we simplify, these 2's cancel out and we get pi r squared. So let's put it all together. Area of a circle is equal to pi r squared. And this is what you have learned in the past. Okay, so write this down, know this formula. Area is equal to pi r squared. I'm not going to make you derive it for me, but you do need to have that formula handy, and it's beneficial if you have it memorized. And then we will formalize it in theorem 8.13. The area of a circle is pi times the square of the radius. So once again, let's see, did they put that in formula form here? Yeah, there we go. So area is equal to pi r squared. Okay, so memorize it, know how to use it. For your assignment, I told you it would be quick. That was a quick lecture. For your assignment, just some reminders. Okay, so some reminders. The diameter of a circle, diameter is equal to 2 times the radius. Okay, so on a circle, this is the diameter. Okay, and this is the radius. Okay, so keep those in mind as you are working through your problems. Also remember that the area for circumference, which is the perimeter of a circle, is 2 pi times the radius. Okay, you're going to need to use these. So now you're going to be given in your homework, which you will find on Google Classroom, you will be given a table in which you have, let me just go ahead and quick sketch this out real quick. You have C, the circumference, and you have R, the radius, and you have D, the diameter, and you have A, the area. Okay, and then what they're going to do is they are going to give you one of these values, and you're going to have to find the others. Okay. And it's going to vary. Sometimes they'll give you C, sometimes they'll give you R, sometimes they'll give you D, sometimes they'll give you A. Let's go ahead and do one of these together. So on number 1, they give you 9 as the radius. Okay, so what is the easiest thing to find if you know that 9 is the radius? Well, we know that the diameter is 2 times the radius, so we know that the diameter is 18. Okay, so you can fill that in. And then we need to find the circumference and the area. So let's go ahead and do circumference. Circumference is 2 pi times the radius. Okay, so circumference equals 2 pi times the radius, and in this case the radius is 9. 2 pi times 9, so we can simplify 18 pi. Leave it as 18 pi. Okay, do not put a decimal form in there. Don't put that in your calculator. Don't round to 3.14. Go ahead and leave it as pi, because that is an exact answer. If you put a decimal in there, it will be an approximation. And then we want to find area. Area is equal to pi r squared. In this case, our r is 9. Pi times 9 squared, which is equal to 81 pi. Once again, you're going to leave it as pi, 81 pi. And you don't need to put the units in this one because they put the units in the headings of your table there. Okay, so that's how you're going to do that. Now, if they give you the circumference, you're going to have to work backwards using your formula to figure out what r is, and then you can use that to find d, and you can use the r to find the area. You'll always be given one, and you'll have to figure out how to find the others. In exercise, in the B section exercises, you're given some shapes. So for example, you're given a square, pretend that's a good square, and it has circles in it, and this is a horrible drawing. You look in your book at number 11. And then what you have to do is you have to find the area of the shaded portion. Okay, so it looks like this. So what you have to do is you have to find the area of the square. So find the area of the square and subtract the area of the circles. Okay, so you're going to have to calculate the area of the square and the area of the circles, and then you're going to have to subtract that out to find the area. Okay, and then there are a few others like that with different variations on that. You might have to go back and look at some of your formulas from previous sections. Please do that. Please don't guess. Please don't try to remember them from memory if you don't have them memorized. If you have any questions, don't hesitate to ask, and reach out to me if you need help.